All right. So let me do another Tor. Let me do a Tor computation. Okay. So I'm not sure if R being a PID is so necessary here, but let's just be safe. Let R be a PID. Okay, and so let A be an element of R. Okay, so we want to compute. And this is, so this one's where Tor gets its name. So we're going to find out that this is going to be a Tor. This is going to be the torsion, the a-Torsion in M. Okay, and so M is going to be an R module. Okay. Okay, so let's just compute it. So to compute this one, so we need a projective resolution. All right, so let's compute the projective resolution. So we have 0 goes to R, goes to R, goes to R mod A. Okay, and so this is what we're resolving. We're resolving R mod A. This is the quotient. Yeah.
I was expecting injective just based on what I remember reading it, but this is
looks like you can do it with projective or injective. So for tors, right? You want the complex to go backwards, right? So, and then I think you can do it with projectives. I need to think about that again before. I don't want to say anything wrong on video. I probably talked about it last video.
Okay. Yeah.
But I want to compute it with. I'm going to compute with projective resolution. There's like all these ways that you can compute these things that are all the same, and but showing that they're all the same takes a little bit of work. But yeah.
Well, I was just making sure you meant to do that because I was just looking at the arrows and I was like, wait a second. Cool.
Yeah. So I do want to do a projective resolution here. Okay. So I'm doing a projective resolution of this one here. Okay. And I'm pretty sure I want to do I want to do a projective resolution here. Okay. So so this is a complete projective resolution. So the image of this is well AR, and that's the kernel of this map. So that makes sense. Okay, so this is an exact sequence. So this again, this part here is the projective resolution. And notice that the kernel of here is 0 because it's a domain. So the kernel of multiplication by A, so maybe I should write this as A, is 0 since R is a domain. Okay, so I guess we haven't really used anything about a PID so far. All right, and so now let's do let's apply the tensor product to this thing. Okay, so we have 0 tensor over R with M. So this is like the C2 part of our complex. So now I'm using like homological notation. So this is R tensor with R over M. Okay, and so this map here is R. So let's do this is multiplication by A tensor with R over M. This is R tensor with R over M, and then we have the 0 part of the complex. Okay, this is just M because the R's cancel. Right, that's the thing we know about tensor products. And this is isomorphic to M. Okay, and then I claim that this map here is also just multiplication by A. Okay, under this isomorphism. Okay, so that's maybe something to check. Okay, so now we have our resolution. So this is C1, and this is C0. Okay, so so these are this is the complex, the chain complex that gives us our Tor. Okay, so now we can compute Tor 0. So Tor 0 of R of M comma R mod A. So what is this thing? So this is the kernel of this map of m to 0 modulo the image of this map here, which is multiplication by a from m to m. So this is m mod am. Okay, notice that this thing is really just m tensor over r with r mod a. Remember, that's one of our formulas that we had for tensor products, right? Remember, we tensor with a module over r mod I, we just do m mod im. Okay, so this is a formula we have. For, you know, tensor products over r mod I for, so this is a general thing. Okay, so let's do Tor 1. M r mod a. Okay, so this is the kernel of, okay, so now we're in degree 1, which is this right here. Okay, and so this is m here, maps to m, and it's multiplication by a. And then the image of this map here, this is 0. Okay, the image of 0 into m. All right, and so what is this? This is just the m-torsion. So this is the kernel of this map. So this is the m-torsion. Or a-Torsion, sorry. A-Torsion in m. So this is MA. Okay, so that's why it's called Tor. Because Tor 1 is the torsion. Okay.
Well, what is m mod am? That almost seems like a torsion thing, but it's not. The result of doing Tor 0.
The quotient, right? So m mod am is not. I mean, it is a torsion, but
but it's not in m, so it's different.
It's not exactly. It's not in m. Yeah, it's the quotient. Yeah. And then so we see that Tor, the higher Tors. Okay, I remember what I was thinking about with the PID thing. So that's about a criteria for when something is flat or not, and so maybe I'll talk about that later. So yeah, so this just works for any domain, I guess. So we never use the PID hypothesis. This is 0 for I greater than or equal to 2. Okay. So yeah, so this is great. So we have this, and so I guess we don't need a PID here. Be a domain. Right, and so now, yeah, so that gives us a formula for Tor. So Tor 1 is the torsion. Tor 1 like this. That's the point. Tor is torsion. Right, that's all right. Okay, so okay, so that's all I'm going to do for today.
Excellent.